arrangement like this. Here and here also you have tensile force. So you are pulling in this way. Here you have tensile force and here also you have tensile force. And these are the bolts which you are providing in the flange here. Okay. So the bolt here, when you see the cross section, you will see only two bolts in the cross section. This is only from the side. Okay. So this will not be available to you. You will see only this figure in the question. Okay.
But you will.
Yeah. Because when you are designing, the question will say, okay, there are two bolts in the flange. Okay.
Two lines.
Yeah, two lines.
Okay.
So determine the required number of this diameter bolts. A490 is the grade of the bolt. For this connection, net load is 14 and live load is 126. So you can easily calculate the design force, which is TU 1.2 times dead load plus 1.6 times live load, and you can get this value as 280. Simple calculation. Then you find the design strength per bolt. Now, which design strength you will calculate? Shear, tension, bearing. Tension, right? Because the bolts are in tension. It is clearly visible from that figure that the bolts are in shear. There is no chance of any shear. Okay. So we calculate only this side. Huh?
لا لا في التنشن والهذا 0.75.
Because this is your F and D. So in case of F and D, what we have been 0.75 FUB. Right? I told you that F and D is equal to 0.75 FUB. So we substitute this value. FUB is available in your table data sheet, which is 150 for this steel grade. And when we substitute, now AB is based on the diameter of the bolt, pi by 4 B square. Right? This is AB. So pi by 4 and the diameter how much? 3 by 4 inch? Square.
Because not plus 1 hour, right?
No, it is only for the bolt, not for the hole. AB is the diameter of the bolt. Not for the hole. Okay. So we get this value as 37.27. It means one bolt will have this much tensile capacity. And now total force is how much? Total force is 280. So now we apply the same rule here. Total tensile force divided by the capacity of one bolt. And you can see here, number of bolts required is equal to total force, which is to be transferred, divided by the capacity of one bolt. And you get how much? 5.8.
You can take 6.
You cannot take 5.84, so you will take 6. Even if it is coming to be 4.5, what will you do? 5 volts?
5.
6.
No, 5 will not be possible because you have to provide at least 2 in 1. So 5 is not possible. So you will go 2, 4, 6, 8 like this, even number.
To resist zigzag,
Huh?
To resist zigzag?
No, there is no zigzag. Because in the flange there will be pairs. 2, 2. So if you increase, otherwise
Yeah,
it
we
will
have to increase by
be not balanced. Okay, so 2 here, 2 here. So 4. If you say 4.5 means 5, you cannot provide 5. You have to provide 6. Even number. What you call in Arabic zawji. Mufrad and
زوجي ومفرد.
Fardi and zawji.
My husband.
Here. Even and odd. Okay. So now you get this value and you get the number of bolts here, and then you can easily say 6 bolts. Now you can draw this figure. This is your figure to be drawn. So you see here 3 on this side here and 3 on this side.
What about distance? Between
Now here the question is only for asking this
number
of bolts. Otherwise you have to decide the diameter and everything, the distance, spacing, then you will go according to that. Because that information is not available about this and this. How much is the flange? width. So in that case, you need that flange width also.
Doctor, the shape will be like this always.
Shape like this. This is the connection. There can be a connection between the two tension members also. Different connections can be there. Okay. Here the force is transferred in this way. So now we come to this example. Bearing connection. And here you will see this. Compute the tensile factor load capacity for the bearing type connection shown below. Here is this connection. There is plate which is overlapping with another plate. You can see in this cross section. And these plates are connected with the help of two lines of bolts. One line here and one line of bolt here. Two lines of bolts. So this is the direction of force. And these spacings are also given. 1.5. And the center to center spacing between these bolt holes is 3 and 1.5 on this side. This is the arrangement which is given, and the diameter of the bolts is given as 7 by 8 inch. Okay, and this is the grade for the bolt material, and steel grade 50 is for the plate, steel plates. So you can get the values of Fy and Fe for the plate, and the values of Fub for the bolt, or Fnb for shear and the welding. And here there are two conditions which you have to check. Bolt threads are excluded from the shear plane. These are the two possibilities in the case of shearing. Or the bolt threads are included in the shear plane. So you have to check for both. Okay. Now we come to this. First, we will check that how much is the capacity of the plate. Our design should not be more than the capacity of the plate. Okay, otherwise it will be uneconomical. So the capacity of the plate is only this much, which is the gross area of the plate. 6 into, this is the thickness of the plate. You see here, plate is given as 5 by 8 inch thickness, and the width of plate 6. So you get the gross area. So based on that gross area, you will calculate the capacity of the plate. So AN, now you calculate AN from gross area. So 6 minus the deduction for the whole.
Yes.
Because now you are calculating the capacity of the plate. So you will deduct for the whole, then you will add. Okay? But if you have to calculate the area of the bolt, you will not use this 1 by 8. When you are making deduction for the whole, then only in the plate you will check. So this is your net area. Now AE is equal to U into A, because here the value of U will be 1, because plate is single member. Okay? It is not angle section, not I section. That's why U is equal to 1. So you put here the value of AN, so effective area will be same as AN because it is fully connected paired member. Now you can calculate for yielding and for rupture. 0.9 into 50, this is for steel grade Fy value. Okay, and this is your gross area, AE. This is the formula which you have used in the previous chapter. Okay. Then for rupture we use Fu value, and here we use net or effective area. So when we substitute these values, we find this 169 kips and 122 kips. That means your plate will fail at 122. So our connection, there is no need to go for more than 122. Okay. So we limit our design strength to be 122. This will be the failure of the plate. Now we come to calculate the capacity of our bolts.
So doctor, on the shear only we do the capacity for the briefest steps.
Where? No? See here? This is for yielding and this is for rupture.
Yeah, I mean in the case of the question asked for shear and give me shear.
No. Question is not asking only for the shear. Compute
So-
the tensile factor load capacity of the bearing type connection. How much force can be transferred? How much of this force can be transferred? That will be possible if all the bolts are transferring the force safely. If the plate has failed or if the connection has failed, that means your joint has failed. You will not be able to transfer that force. Okay? So we find the capacity of the plate and capacity of the connection. Whichever is the least, that will be the force which can be transferred through this arrangement.
Both of the side and the tip will be given.
Huh?
Side and tip view.
Yeah, this will be given. This will be given because you need these dimensions. Cross section, what are the plates, how the plates are arranged. This will be available. But in the case of shear, these conditions will be checked. Okay? So both of these will be checked. But you have to check for tension, you have to check for bearing, you have to check for shearing, both cases. If it is not given in the question, you can go for one case. Which one you will go? Yes. Threads included or threads excluded. When the threads are excluded, you will use 0.5, you will see that formula. Okay. Then go on the lower side to be more conservative, so that there is no chance of this type of failure. Now we come to this. So for shear, now there are two cases in the case of shear. Threads excluded, and as I told you, see here, you are using 0.5. The capacity is taken as 0.5 of FUB, then M into area of the bolt. M is the number of shear planes, which is equal to 1 in this case. Why? See this figure again. Shear planes, only one. Okay? Two plates are overlapping, so shear plane is 1. Therefore, we put 1 here. And because here threads are excluded from shear plane, we will take this value 0.5 FUB. And when the threads are included, this will become 0.4. That will be the only difference in the formula.
Dr. M is the number of shear blade.
Shear planes? 1. Because the plates are like this. And here is your bolt. So shearing only at 1 plane. Okay. So we get the strength for 1 bolt. 27.1 gives for 1 bolt. It's shearing. Huh?
Maybe the area for both.
Area for the bolt, yes. This is the area for the bolt. Pi by 4 d square. And this value you will take 0.5 FUB for the case of threads excluded from shear plane. Then we come for bearing. In the case of bearing, you will measure the values of this bearing distance, LC. Because in the formula for bearing, we need LC. For LC, now we go back to this figure. See here. That will be your LC
1.5 minus.
here or this LC. Out of these, which one is minimum, that will be taken. So here you can say from 1.5, if I subtract half of the diameter, or from this T, if I subtract half diameter here, half diameter here, that will be my LC value. LC, clear length. That will be used in the formula for bearing strength. So we calculated here two values for LC, 1.5, that distance for the edge, minus half of this value, because here 7 by 8 plus 1 by 16, which is for that. So similarly here, this is center to center, and from that center to center we subtract that distance, and this is now clear length. So least value is 1.03. You will take this value.
Why did you want to like 0.5?
Huh?
And,
Half of the diameter only, because it is on the edge. See here? Only this. Half diameter only you will subtract from this value. Half diameter. Okay. But in this case, in the middle part, from this, half from here and half from here. One diameter, which you can see here, this is subtracted like this. So we have got the values for LC, then you can calculate from that formula 1.2 times LCTFU. Okay. So here to be on the safe side, we take 1.2 if it is not given in the question, because there are two values, either 1.2 or 1.5. Okay. So if it is mentioned, okay, you will take according to that. If it is not mentioned, you will go on the lower side.
If it's mentioned what, doctor?
It is not mentioned here.
About what? I mentioned what?
About the type of hose, because if you see bearing, long slotted hose or standard hose, that condition is there. If there is nothing mentioned, you will consider only the standard hose.
No, doctor, 1.5 is for bearing.
Yeah, bearing there are two values, either 1.2 or 1.5, both are there. Okay?
And there is one.
Huh?
There is one.
There is one for different case. One for different case. Yes. Okay. So here we take this value and here we calculate based on that 1.2 times LCTFU 0.75 is this value of 5, 1.2, and then LC value you will take from here, this value, and then T is the thickness of the plate, and FU, this is FU. Okay. So we substitute all these values, we get 37.65. This is the bearing strength of one bolt. Okay. So we calculated both. This is for the bolt and this is for the criteria of plate. Okay. Then the shear control. So shear is how much? 27.1 only. Bearing 37.6. Therefore, the capacity of the bolt will be only 27.1. It will fail at 27.1, which will be in the shearing. In the bearing, the values are very high, 64 or 37. So the chances of failure will be in the shearing, 27.1. Therefore, how many bolts are there? 4 bolts. One bolt has a capacity of 27.1. 4 bolts will have a capacity of 4 into 27.1. So the capacity will be only 108 kilopounds, which is less than the capacity of the plate. That means the joint will fail at 108. So you will not be able to transfer a load of 122. Right? So capacity of the connection is only 108.
It's fair in this shape.
Huh?
It's fair in this shape.
If it fails here, then it will be this value. Suppose you get this capacity 108, bolts 108, plates only 90. That means the plate will fail before the bolts.
The plate will take time.
Plate will be responsible for this failure. Okay. That means the transfer will be only 90. Not more than 90 can be transferred to that. That is the case. Whatever be the bolts, you provide 10 bolts, no value. Okay. So this is what we have, and then we come to the second part where threads are included in the shear plane, and in that case we will just replace it by 0.4. So less strength is taken here. So that is that. Because of that, the area will be reduced. So instead of that calculation of the area, using that fraction and so many things, they are directly reducing this strength and making it, instead of 0.5, this is written as 0.4. So that 10% reduction has been taken because of that reduction in the diameter because of the threads. So all these things are same here, only this difference. So we get this value is 21 points. So you see this value will be less when the threads are included in the shear plane. And all other things will be same because there is no difference, only this will be considered. So we get this value as 21.6 in this case, and the capacity of the plate, all these shearing, everything is same. So the capacity will now be reduced to only 86.4 in this case. In the shearing it will be same. In the case of bearing also it will be same. Only because of this condition it will be reducing. So failure will be at 21.6 and you will get 4 bolts. So 4 into 21.6.
خلاص دكتور.
Here, Yes. If you want, you can do one practice question, but you can see I gave one similar question to the other group on Monday class. Just change the values, okay? So this will be the only difference. Maybe the diameter different or thickness of plate different. These things only. But there you are
You will
calculating
send
that.
the question in the group or
Huh?
write the question here or send in the group.
Maybe you can ask them, they can send you.
Okay, okay.
Yes.
Okay.
A similar type of practice question.